Hello and namaste to all of you. Today, in our Sustainable Development Goal 2030, we are doing Unit 2.2 Environmental Calamities. In this Unit 2.2, we have already covered in our audio number 25. Number 1, the introduction, aims and objectives, and number 2, natural calamities. In this audio number 26, we will cover point number 1, earthquakes, point number 2, floods, point number 3, droughts, and next cyclones and then tsunamis. It is useful for school students, and particularly it is used in the arrangement period for schools. Students have to listen the audio very carefully and note down 10 words from this audio number 26. Now we will begin the Unit 2.2 Environmental Calamities. 2.3, 2.1, 2 we have already covered. Point 3, that is earthquakes. Ancient people believed that earthquakes occur whenever evil deeds outweigh the good deeds on earth. Subsequently, earthquakes were known to have resulted due to the rumbling sound in earth caused by the movement of hot air masses trying to escape from the hollowed outer parts of earth's interior. With the invention of high sensitive seismic instruments and advancement of science and studying the pre and post effects of earthquakes in different parts of the world, the geoscientists and seismologists are able to explain the possible reasons for the occurrence of earthquakes. But there have been different explanations for earthquakes in different parts of the world. It is now generally accepted that an earthquake is a vibration of the earth produced by the release of energy. This energy radiates in all directions from its source, epicenter. Earthquakes can also occur because of atomic nuclear explosions or by volcanic eruptions. Large reservoirs with their hydrostatic pressure of water may also induce earthquakes. India has been divided into 5 zones depending on the vulnerability to earthquakes. They are Zone 5. This is the most severe seismic zone and is referred here to as very high damage risk zone. Zone 4. This is referred as here to as high damage risk zone. Zone 3rd. This is termed here to as moderate damage risk zone. Zone 2nd. This zone is referred to as low damage risk zone. Zone 1st. This zone is termed here to as very low damage risk zone. The 1999 earthquake in Izmit, Turkey. On 17th August 1999, an earthquake with a magnitude of 7.4 to 7.8 on the Richter scale hit the city of Izmit, Turkey, and the surrounding areas. Damage from the earthquake was estimated at more than US $13 billion. More than 15,000 people were killed, 25,000 others were injured, and 600,000 people were left homeless. The earthquake was blamed for increasing the national account deficit of some US $3 billion in 1999 to 2000, equivalent to about 1.5% of the GNP. A significant part of the damage could have been avoided had local building codes been effectively implemented. Many new buildings had not been properly designed. had not been built on foundations strong enough to resist earthquakes and had not been sited in areas where the effects of earthquakes would have been diminished. In order to understand the strength and severity of an earthquake, it is necessary to measure its intensity. There are several methods to measure the intensity of the effect an earthquake produces on life and property. Two Italian seismologists, Rossi and Forel, introduced a scale known by their names. It consists of 10 divisions. The higher the number on the scale, the greater will be the damage caused. This scale was found to be unsuitable and subsequently Mercalli Mercalli scale or Richter scale was introduced. The Richter scale describes the amplitude of the earthquake wave radiating out in all directions from the focus epicenter, which is closely related to the amount of energy released. This is also a measure of ground motion as recorded on a seismograph. A relation between the Mercalli number characteristic and the Richter scale are given in the following table. Mercalli number 1, effect instrumental, characteristic detected by seismographs, Richter scale less than 3.5. Mercalli number 2, feeble, effect feeble, characteristic noticed by some people at rest, Richter scale 3.5. Mercalli number 3, effect slight, characteristic similar to vibration of a passing truck, Richter scale 4.2. Mercalli number 4, effect moderate, characteristic felt indoors, parked cars, rock, Richter scale 4.5. Mercalli number 5, effect rather strong, characteristic most sleepers wake up, Richter scale 4.8. Mercalli number 6, effect strong, trees sway, furniture moves, some damage caused, Richter scale 5.4. Mercalli number 7, effect very strong, characteristic general alarm, walls crack, Richter scale 6.1. Mercalli number 8, effect destructive, characteristic weak structure damaged, Richter scale 6.5. Mercalli number 9, effect ruinous, characteristic houses collapse, ground cracks, Richter scale 6.9. Mercalli number 10, effect disastrous, characteristic many buildings destroyed, raised, rails bend, Richter scale 7.3. Mercalli number 11, effect very disastrous, characteristic few buildings survive, landslides occur, Richter scale 8.1. Mercalli number 12, effect catastrophic, characteristic total destruction, ground greater than formed waves, Richter scale 8.1. The number, scale and characteristics are many times deceptive. There have been instances when a lower number caused most severe damage depending on the distance of the place to the focus epicenter, the density of population, the nature of civil constructions, the nature of the ground, and the concentration of physical structures on the ground. There have been experiments to predict an earthquake and determine the zones that are prone to the earthquakes. However, most of them do not prove to be very satisfactory. For example, changes in seismicity, physicochemical changes, changes in landforms, changes in animals' behavior are some of the parameters that could lead to the prediction of an earthquake. Though Various theories have been developed in the method of prediction. A practical level none seems to work. Of late, several strategies have been proposed artificially artificially inducing controllable earthquakes of very small intensity to reduce the building up of energy in the earth's crust or release the stress before it reaches critical levels through underground nuclear explosions. But these may turn out to be uncontrollable, to be experimented beyond the laboratories. It is now accepted that people must be made aware of the methods of minimizing the risks. Training the public in earthquake resistance construction in the prone areas may yield some results. Number one, the The moment magnitude MW 7.6 Bhuj earthquake that shook the Indian state of Gujarat in the morning of January 26, 2001, Republic Day, is one of the two most deadly earthquakes to strike India in its recorded history. 1 month after the earthquake, the Government of India figures placed the death toll at 19,727 and the number of injured at 166,000. Indications are the 600,000 people were left homeless, with 348,000 houses destroyed and an additional 844,000 damaged. The Indian State Department estimates that the earthquake affected directly or indirectly 15.9 million people out of a total population of 37.8 million. More than 20,000 cattle were reported killed. Government estimated the direct economic losses at $1.3 billion. Other estimates indicate losses may be as high as $5 billion. Number 2. An earthquake with a magnitude of 7.6 on Richter scale hit the Kashmir and Pakistan administered Kashmir region on 8th October 2005, which has claimed more than 100,000 lives, has resulted in large-scale damage in terms of human life and property worth crores of rupees. An estimated 3.3 million were rendered homeless. With the onset of the winter, many people face the risk of dying from cold and spread of disease. According to the official estimates, in Pakistan alone, the damages incurred are over 5 billion US dollars. On the Indian side of Kashmir, over 1,800 people lost their lives, while the difficult terrains pose enormous challenges for the relief material to reach the affected areas. The region's high altitude throws open the risk of exposure to cold weather. Point 4. Floods. Floods are the most common of all natural calamities. Floods regularly claim over 20,000 lives and adversely affect 75 million population annually worldwide. Bangladesh alone is by far the most flood-prone country, accounting for about two-thirds of global loss of life. India accounts one-fifth of global death count and loss of rupees 600 million every year on an average. More than the loss of life and damage to property, millions of people are displaced every year due to floods in the South Asian countries. Number 2. Floods kill dozens in South Asia, millions homeless. The mighty Brahmaputra River, swollen by rain and a Himalayan burst dam, has flooded huge swaths of North India and Bangladesh, killing dozens of and forcing millions to seek refuge on higher ground in June-July 2004. In Assam, that brought the death toll from the annual monsoon floods to more than 70 in India and neighboring Nepal. In neighboring Bangladesh, officials said 13 people had died and an estimated 3 million people were marooned, cut off in their flooded homes and on patches of high ground. In the eastern Indian states of Assam and Bihar, military helicopters and soldiers in motorboats tried to rescue thousands of stranded people and dropped cooked food. All rivers in Assam, including the main Brahmaputra, were overflowing after a week of incessant rains, and more than 2 million people have become homeless because of floods. Dam bursts in the impoverished state of Bihar. At least 14 people were drowned in two separate incidents on Saturday when their boats capsized in the swollen Bagmati River. More than 600,000 people had been affected in Bihar. A dam at Tisatitsu Lake in the Himalayan kingdom of Bhutan had burst, spilling water into tributaries of the Brahmaputra and swelling the floods in Assam, a flood control official said. Floods and landslides have left thousands stranded on high ground in the neighboring mountainous kingdom of Nepal, killing at least 12 people, an official said. While Assam and Bihar are battling floods, the northwestern and central regions of India have had less rain than normal so far in the June September monsoon, raising doubts about the fate of major crops such as rice and oilseed crops. The northeastern Bangladesh town of Sylhet at the center of the worst hit district lay under 60 centimeters 2 feet of water, and road and rail links were cut or threatened by the rising water. The floods now covered nearly 20 to 64 administrative districts. Thousands of families had sought refuge on roads and embankments as well as in schools, government buildings, and boats after the floods forced them to abandon homes. A flood is the discharge of water that exceeds the canal capacity of the river. Floods are caused by different factors that include number one, climate extremes, heavy and prolonged rainfall. Number two, melting of snow and ice. Number three, collapse of dams. Number four, landslides. Number five, silting of riverbeds, reducing the carrying capacity of rivers. Number six, lack of coordination between officials of adjoining districts or states facing similar problems. There was a case study of two adjoining districts, for example, A and B, that were threatened by floods. The canals flowing from District A were bringing huge quantities of water into villages in District B. There was one canal which breached off from District A into drier areas. Since its elevation was higher, it was not carrying any water, resulting in heavy inflow of water into District B. The collector of District B, in consultation with his counterpart in District A, installed pumps a little upstream, hand pumped water into the canal flowing into drier areas. This not only saved many villages of District B from inundation but also resulted in meaningful use of surplus floodwater for irrigation of dry areas. The collector of District A, however, had to pacify the political discontent and control the misinformation about raising water levels in his district. This may be only an exceptional example, not possible to apply everywhere, but highlights the point that the officials on field, if they search for solutions, can find solutions that may reduce the effects of floods and alleviate the suffering of people and save the properties. It is possible to reduce the adverse effects of floods by number 1, construction of dams and reservoirs at appropriate places. Number 2, strengthening the embankments on rivers and canals. Number 3, improving the carrying capacities of rivers, canals and reservoirs by periodical desilting and deepening operations. Number 4, enhancing the deepening, widening and lining of canals and periodically deepening and desilting the drainage channels. Number 5. Diversion of flood waters from a river or a channel into other canals and channels. Number 6. Introducing floodplain management techniques. Number 7. Prepare natural ponds, reservoirs, tanks and leading channels by removing obstructions and avoiding constructions. Though it is known or easy to predict beforehand the onset of floods, the administration and people more often than not do not wake up to the situation before it is too late to press into service the preventive measures. A study of the damage caused by the floods often indicate that the damage to property and loss of life or displacement of people could be reduced if only the government agencies coordinate their activities and act in time to address the calamity. Flood management. How effective is the flood management in India? Going by the records and observations every year, it can be said that these challenges continue to increase, be it in Assam, Gujarat, or southern parts of India. One of the worst examples is the recent flood management in Mumbai, the financial capital of India, as torrential rains lashed the city. The government's slow response added to the crisis. The encroachments along the banks of the Mithi River has exacerbated the situation, blocking the flow of the river, with the city facing immense floods and the blockage of drains due to plastic bags. The old buildings too gave way by crumbling, and with regard to healthcare, people complaining of fevers and diarrhea, while there are no regulations regarding these menaces. One can sense the lack of effective laws that would go a long way in providing better civic amenities to the citizens. Often concerns are raised by the NGOs and civil society. Nevertheless, the gap between the policy making and policy implementation continues to widen, exposing the lack of initiatives by the government, by the governmental and civic agencies, and their poor crisis management. It can be aptly said that the human failures prove to be bigger disasters than the natural disasters. Number 5. Droughts. A drought can be defined as a prolonged period of unusually dry weather with little rainfall in a region where rains are normally expected. As such, a drought differs from a dry climate, which is usually associated with a region that is normally or seasonally dry. Droughts often last for years. Drought is a creeping calamity because it develops slowly and has a prolonged existence. Droughts are not confined to any particular tectonic or topographic setting, and their impact extends over very large areas and regions. The impact of drought affects the developing countries more severely than the developed countries. The early effects of drought from endemic seasonal hunger and the resulting malnutrition cause immense misery to the poor people. Drought. Rajasthan, the largest state in India with a land area of 3.42 check square kilometer and an estimated population of about 54 million in the year 2000 is in the grip of a severe drought. Out of the 32 total districts in the state, drought is prevalent in 31 districts, and among these, 25 districts are affected severely. 73.64% villages are under the clutches of drought, affecting nearly 33.04 million people and 39.97 million cattle. The severity of the drought can be judged from the fact that out of a total of 2647 to 2647 major water reservoirs, only 300 were filled this year. Also, nearly 75% to 100% crop has been destroyed due to water scarcity. All this has caused loss of livelihood leading to mass migration in search of employment. Groundwater depletion. Groundwater is a major source of drinking water. Its usage has been estimated at around 50%, but much of its availability is dependent on the rainfall and recharge conditions. While the demand is on the rise, it has also led to water scarcity, and where available, it is afflicted by pollution. The environmental degradation further accentuates the problem, depriving millions of people an access to safe drinking water. This kind of crisis is more a man-made crisis than a natural one. The extraction levels have gone up, and even the farming and industrial sectors are increasingly using the water from wells. Often there is an indiscriminate use. The crisis can be attributed to lack of adequate water conservation methods, inefficient use of water, groundwater recharge, and lack of quality in freshwater sources. The water pollution is marked by excess fluoride, arsenic, iron, or the ingress of salt water. Water harvesting measures. One of the effective measures to combat drought and the resulting water shortage is to adopt water harvesting measures. It means capturing rainwater. It means capturing rain where it falls or capturing the runoff in your own village or town and taking measures to keep that water clean by not allowing polluting activities to take place in the catchment. Therefore, water harvesting can be undertaken through a variety of ways. Number one, capturing runoff from rooftops. Number two, capturing runoff from local catchments. Number three, capturing seasonal floodwaters from local streams. Number four, conserving water through watershed management. These techniques can serve the following purposes. Number one, provide drinking water. Number two, provide irrigation water. Number three, increase groundwater recharge. Number four, reduce stormwater discharges, urban floods, and overloading of sewage treatment plants. Number five, reduce seawater ingress in coastal areas. In general, water harvesting is the activity of direct collection of rainwater. The rainwater collected can be stored for direct use or can be recharged into the groundwater. Rain is the first form of water that we know in the hydrological water cycle. Hence, it is a primary source of water for us. Rivers, lakes, and groundwater are all secondary sources of water. In present time, we depend entirely on such secondary sources of water. In the process, it is forgotten that rain is the ultimate source that feeds all these secondary sources and remain ignorant of its value. Water harvesting means to understand the value of rain and to make optimum use of the rainwater at the place where it falls. Droughts could be classified into four types. Number one, meteorological drought, rainfall deficit. Number two, hydrological drought, river flow deficit. Number three, agricultural drought, soil moisture deficit. Number four, famine drought, food deficit. Though climate is usually the prime triggering of drought, the situation is often made worse by the way people use the water resources, felling trees for firewood, denuding the forest for agricultural or housing purposes, mining, unscientific farming methods, and indiscriminate drawing of groundwater causes droughts. It is argued that serious droughts in developing countries are more a function of global developmental policies than climatic conditions. Droughts produce series of direct or indirect impacts that usually extend far beyond the area that is experiencing the actual water shortage. These may be classified as number one, economic loss of crop, dairy, livestock, fishery produce. Number two, environmental damage to plant and animal species, erosion of soils. Number three, social food shortage, damage to health, conflicts between water users. It is possible to take precautions in drought prone areas by constructing reservoirs, educating people in water conservation, scientific farming, and optimal use of groundwater resources. Groundwater, which is found in aquifers below the surface of the earth, is one of the most important natural resources. Groundwater has about 38% of the water, and the city water department supply this to households and businesses. Public supply. It caters to the need of drinking water for more than 97% of the rural population. The Hyderabad Metropolitan Water Supply and Sewage Board (HMWSSB) has set up an ambitious plan of taking up several water harvesting measures in twin cities of Hyderabad and Sikandrabad and its vicinity through active involvement of people during the next 1 year to improve the groundwater level. The water harvesting measures under the Niru Miru Water and You program include construction of a recharge pit or a mini treatment unit, planting a sapling or any other action that would improve water recharge, green cover which ultimately increase the groundwater levels. Explaining the motivational strategy at length, the government officials said that they have plans to sensitize different opinion makers like ex-servicemen, retired officials, women's group and NGOs. The groups would be sensitized on motivational aspects and techniques of various water harvesting structures. The trained groups would in turn reach out to communities and motivate the people, highlighting the importance of rainwater harvesting and its benefits. As part of the strategy, the board has recently created water soldiers. By sensitizing ex-servicemen recently, it had also proposed to involve the student community in a big way so that the schools and colleges and other institutions would contribute to the cause of improving groundwater table, thus enabling it to cover 25% of the 7 lakh houses with one or other type of water harvesting method. Next, point 6, the cyclones we will discuss in our next audio number 27th. Okay, thank you.